Welcome back to lesson 17, or I should say, welcome back to math, Saxon Math, course 1, lesson 17. This is the number line. We're looking at fractions and mixed numbers. I'm going to talk fairly quickly. Remember, you have the ability to pause and rewind so that if you miss something, you can review it again and again and again if you need to, just like reading in your textbook. All right, here's a number line. Point A represents the mixed number 2 and 3/5. It is not an integer. An integer would be something like the digits 1, 2, 3, goes on to infinity. It's also be -1, -2, -3 on to infinity, that direction. But this would be considered a mixed number because it's a fraction, or it's a mix between a whole number value and a fraction value. If you look at it, you can see that A is represented in this case. You see it's past the 2, and then it's 1, 2, 3 equal parts away from the 2. Here's the 4th equal part, and here's the 5th equal part. So you can see the denominator is going to be 5. And then since it's the third one out of 5, it's 3/5. But you can't forget to have the whole number included in that. So here is your mixed number value, 2 and 3/5 for this point on the number line, point A. If it happened to be this point right here, it would be 2 and 2/5. This would be 2 and 1/5. This one would be 2 and 4/5. This number right here, this point on the number line, would be 1 because it's past the 1 whole value, and it's 1/5. So that'd be 1 and 1/5 because these are 5 equal parts in between each of the whole numbers listed here. So segments past the unit number are what the numerator stands for. Segments past the unit. So if you're at the 2, that's one full unit. And the number of segments in an entire unit, from like 1 to 2, or even 0 to 1, you can see that this particular number line is broken into 5 equal segments. So that's the denominator version. So, and then the number of units. Using your rulers, you can divide. Most rulers would come out into 16ths. So you can see here between 2 and 3, if we counted the number of tick marks between this integer 2 and this integer 3, you would find that there are 16 of them. So this is 1/16. 2/16 actually reduces to 1/8, but it's also 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, and 15/16. And then this last one is one whole value, which is 16/16, which equals one whole value. From here to here is one whole unit. So from this point all the way to this point on the ruler, that's one whole unit. Same with this one. From here to here, from 0 to 1, that's one whole unit. In between there, you can see there's 16 tick marks. Those are called 16ths. You can count by 16ths and reduce whenever possible. So like this was 2/16. That's the same as 1/8. 2/16 is equal to 1/8. If you were to look at 4/16, 4/16 is the same as 1/4 because they're both divisible by 4. You can see that, hopefully. 4 divided by 4 is 1. 16 divided by 4 is 4. So you can see 4/16 is the same exact measure as 1/4. You can see here that this is 5/16, this is 6/16. 6/16 would reduce to 3/8. Both the numerator and the denominator are divisible by 2. So you can see 6 divided by 2 is 3, 16 divided by 2 is 8. So this is considered a new concept, but let's just look at it again here closely. So on this number line, the tick marks show the location of the integers. So -3, -2, -1, 0, 1, 2, 3, 4. Recall that integers are the set of counting numbers, their opposites, and 0. So all of those would be considered numbers or integers. There are points on the number line between the integers that can be named with fractions or mixed numbers. A mixed number is a whole number plus a fraction. Halfway between 0 and 1 is 1/2, but halfway between 1 and 2 would be considered 1 and 1/2. Halfway between -1 and -2 would be a -1.5. So if we were right here, this would be -1.5. So it's actually a mixed number in that it's got the whole number integer, but then a halfway point between those two whole number values or integers. We can count from 0 both directions. The distance between consecutive integers on a number line may be divided into halves, thirds, fourths, fifths, or any other number of equal divisions. To determine which fraction or mixed number is represented by a point on the number line, we follow the steps described in the next example. So if you've got point A on is what mixed number on this particular number line, if you look at it, you can see it's the same example we looked at previously, but you can see that it's 1, 2, it's the third out of 4, 5 equal parts between 2 and 3. So the mixed number would be 2 and 3/5 because it's the second whole value, and the fraction part it's the third out of 5 total. All right, what about our rulers? Well, the rulers you can see are broken down usually just like this, a number line, except they normally don't have negative numbers. But you can also break these down into fourths. So we could have each one of these would be split into half. So each of these would represent a fourth. And we could even break it down farther and actually split those fourths in half again, which would make eighths. So each of these right now, those red ones represent halves. So you can see between 0 and 1 is a half there. This would be considered 1/4 right here. This would be 2/4. This would be 3/4 right here. This one would be another fourth. And this one would be another 3/4. This would be another fourth. This would be another 3/4. This would be another fourth. This would be another 3/4. So not 3/3, but 3/4. And it goes the same direction opposite. This would be the fourth. This would be 3/4. We're looking at negatives though here. This would be a -1 1/4. This would be a -1 3/4. So you have to remember the whole value comes before the fraction piece of it. So let's try, let's just look at a couple examples. What would this represent, this letter A? Well, letter A you can see is between 1 and 2, so it's going to be 1 whole. And then I see that there's 1, 2, 3, 4, and it's the third position of 4 equal parts. So A is 1 3/4. 2 is also a 2 whole, but then it is 1 out of 4. It's the first one out of 4 equal parts. This one would be passed beyond the 3, so this is 3, and I see 1, 2, 3. It's the third position of 4 equal parts, so that would be letter C. If we were going to add eighths to these particular rulers, let me just add them right here. You would just split each of those into half of a half or half of a fourth. And in this case, this is adding in the eighths. So each one of those would represent an eighth. This would be 1/8. This would be the same as 2/8. This would be the same as 3/8. This would be the same as 4/8, and it's reduced to 1/2. This would be the same as 5/8. This would be the same as 6/8, and it reduces to 3/4. This is the same as 7/8. This would be the same as 8/8. 8/8, 8 divided by 8 is 1. Notice that. This would be the same as, and usually once we get past the 1, then we usually just start over again. We have another eighth. We just have to recall that this would be 8/8. It could be the same as 9/8, or it could be the same as the mixed number 1 and 1/8 for this position. So keep that in mind. If we were counting the eighths from 0, there would be 9/8 to this point, or it would be 1 whole. You've got the 1 whole value plus 1/8. In this one, you'd still have 2/8 again, or similar to this particular problem, you could have it be 10/8, which also is the same as 1, and if it was reduced, it'd be 1 1/4, which is basically the same as 1 2/8. This is the reduced fraction. That would be the best answer out of the choices that you'd have. 3/8. So this would be 1 3/8 for this position. This would be the same as 4/8. This would be the same as 5/8. If it's odd numbers like this, odd and an even number, that usually means they can't be reduced. Sometimes they can, so you have to be careful about that. This one would be the same as 6/8. This would be the same as 7/8. And here's 8/8. So that would be adding eighths to your ruler. If we were to add 16ths, I'll just do a couple of them here. This would be the eighths, and then the 16ths would be these. So here's an eighth, and here's a 16th. Here's an eighth, and here's a 16th. Here's an eighth, and here's a 16th. How do I know they're 16ths? Because if I was to count however many equal parts I now have, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each one of those is 16. So this is now considered 1/16 right here. This would be the same as 2/16, which is also equal to 1/8, because 2 divided by 2 is 2, 16 divided by 2 is 8. This one in this position right here would be 3/16. This would be considered 4/16, and that's the same as 1/4. This would be 5/16. This would be 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, and 15/16. And finally, I'll just end it on this one, 16/16. It's the same as 1. So you can see each one of those represents a value out of 16 total equal parts that between 0 and 1. And it's the same over here. If I was to split these up, this would be an eighth, this would be a 16th, 16th. Here's an eighth because this is a fourth. And if I divide an eighth into 2, then I've now got 16ths. Here's another eighth, and here's another 16th. Here's another eighth, and here's another 16th. Okay. So use your ruler to find the length of this line segment. So let me just show you, looking at rulers. If we have, let's do, it says inches, so I'm going to use top one is going to be in inches. So if I was to look at this particular line on here, I'm seeing that it goes past the 5. So this on my ruler is going to be 5 holes, and then I count. I see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 or 10. So it looks like it's going to be closer to 9 because here's where it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. So that'd be 9/16. So this one would be 5 and 9/16 inches for this particular line, because you can see I'm past the 5 holes, and I look at the tick marks. I counted 9 of them, and I know that if I continue to count, this would be 10, 11, 12, 13, 14, 15, 16 sixteenths makes another whole value. So those are by sixteenths. All right. Let's see if we can, let me try to get our practice problems in here real quick. Looks like the practice problems for today, we're looking at these practice numbers here. So let me just bring those in. Just ignore that there for a second. So this is the practice set. And let me delete that. Our practice set. So looking at letter A, it says continue this sequence to 1/2. So in this case, you've got half here. And if you were to look at the next one, if it's going by, it looks like eighths, or actually sixteenths even further. So this would be 8/16. This would be the same as 9/16 here. Then it would go to 10/16. And after 10/16, then I have 11/16, 12/16, and I'm not going to reduce these right now. This would be 13/16, 14/16 would be the next one. Then 15/16. Then I'd have 16/16, which would be the same as 1 whole. And then I'd have 1 and 1/16. Then I'd have 1 and 2/16. And then I'd have 1 and 3/16. Then I'd have 1 and 4/16. Then I'd have 1 and 5/16. 1 and 6/16. 1 and 7/16. And then 1 and 8/16. So, and if I reduce the 8/16, that's the same as 1.5. This would be the end of it right here. 1.5 is the same as 1 and 8/16. So that's kind of a long span here that they made us do. And then each of these would be reduced. You would be able to reduce each of these items, because this one, 10 divided by 2 is the same as 5. 16 divided by 2 is the same as 8. So this would be reduced to 5/8. This would be the same as, both of those are divisible by 4. So that'd be 3/4. This would be, both are divisible by 2. So that would be 7/8. This would be 1, you can see there. This would be the same as 1 and 1/8. This one would be the same as 1 and 1/4. This would be the same as 1, and in that case, both of them are divisible by 2, 3/8. And then 1 and 8/16 is the same as 1.5. That's a long one. I'm surprised the book had us do that, but that's what it would be. Letter B, what number is halfway between -2 and -3? So if you're on a number line, let me just draw a quick number line. You got -2 and you have -3, and you're just looking for the halfway point between it. It would be, and it actually be -2 would be on this side on the number line, because we're looking at negative numbers. So we'd have -3 over here, -2 over here, and we're halfway between those two. if we were to move this over and this was -1, and then this would be about 0 right here. Halfway here would be -1/2. Here would be -1.5. And this one is simply -2.5. So that'd be the answer for letter B. Letter C, what number is halfway between 2 and 5? So let's just answer this piece because the Ed puzzle won't allow us to draw number lines on there. So what is the number that's halfway between 2 and 5? I'll give you the number line. It'd be, if we had 2 here, we'd have 5 here, and then we'd have 3 and 4. So 3 and 4. Looks like it'd have to be somewhere in the middle here. If we went 1 this way and 1 this way, now we got to go halfway between the 3 and the 4. So that would be your number, should be 3.5. Letter D, point A represents what mixed number on this number line? Well, you have, in this case, you can see that it's past the 1 whole value, and then it would be 1, 2, 3, 4. The fifth one out of 6 equal parts. So that would be 1 5/6. And then letter E, you'll have to use your textbook to measure letter E. Letter F, same thing, use your textbook. Go ahead and measure that in your textbook. And letter G, you'll have to use your textbook to measure that one. Okay, and I won't show you using my digital ruler because it won't match up to the textbook amount. But use those lengths in your textbook to measure to the nearest 16th of an inch. So to the nearest 16th of an inch. All right, and make sure you guys do your written practice 1 through 30 during class period. You have 50-minute class period and study periods throughout the day when people have band and you don't. Make sure you're using your time wisely in school so that you have less homework. There should be 0 homework, to be honest with you, aside from this Ed puzzle. All right, have a good night, and we'll catch you next time.